You can operate with complex numbers in the same way you would operate with other binomials. Simplify the following operations. If I had this complex number 3 plus 4i and I wanted to add to it this one 6 minus 3i, I'm essentially going to combine the real parts and get 9, and then combine the imaginary parts. 4i minus 3i is 1i, because it's 1. I'm not going to write the 1 in front. Now my answer is a plus bi form, so always put the real part first. We can subtract them by essentially distributing the negative through here to both the real and imaginary parts of our second complex number. So 4 minus 2i would be plus a negative 7 minus 3i. Or 4 minus 7 gives me negative 3. Negative 2i minus 3i gives me minus 5i. So that's what that would simplify into. Now, when we multiply, we FOIL just like before. So first times first, 4 times 5 is 20, plus outside times outside is minus 8i, plus inside times inside is plus 15i, and then last times last, 3 times a negative 2 is minus 6, I times I is I squared. But keep in mind that I squared is a negative 1, so essentially I have negative 6 here times negative 1, which is a positive 6. So combining real part to real part, 20 plus 6 gives me 26. Combining imaginary part, negative 8i plus 15i is plus 7i. A plus bi form, we want the real part followed by the imaginary part, 26 plus 7i. So squaring a complex number means taking it times itself. So, you know, if you have to recopy this, that's fine, but first times first, 2 times 2 is 4. Outside times outside would be 2 root 3i. Inside times inside is plus another 2 root 3i. And last times last, root 3 times root 3 is 3. I times I is I squared. So just like before, this is going to become 3 times negative 1 or negative 3. Now, 4 minus 3 is 1. That's the A part. The BI part is 2 root 3i and another 2 root 3i, or 4 root 3i. A plus BI form. Now, earlier I said you should never have I to a higher power than 1. So here we have I to the 21st power. If I take 21 and divide it by 4, it's going to cycle through that pattern 5 times. So it'll be I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1. I'll do this 5 times. I will have 3 of them listed. And I'll have a remainder here. Okay, if I get rid of the whole number and I multiply it back through, it has a remainder of 1. So it goes in through this pattern 5 times, and then 1 left over. So I to the 21st is the same as I to the 1st, or just I. In the same way with this one, if I take 63 and divide it by 4, it's going to cycle through this pattern 15 times with a remainder of 3/4. That's 0.75 as a decimal, or remainder of 3. So cycle through 15 times, and then I to the 1st, 2nd, 3rd is the same as I to the 3rd. or negative I. All right. What if we have complex numbers divided by each other? Just like with imaginary or with irrationals, we're going to have to take top and bottom times the conjugate 3 plus 4i, because I essentially is the square root of a negative. If you're thinking of a square root, you have to multiply it by the conjugate of the square root thing down here to get rid of it. So we got to do the same thing with these imaginaries. Now up top we got a FOIL. 2 times 3 is 6 plus 8i plus 3i. I times 4i squared, if you remember, is basically 4i squared or net minus 4. Over down here, 3 times 3 is 9. O's and i's drop. Negative 4 times positive 4 is negative 16, but I times I is a negative 1. Negative 16 times negative 1 is plus 16. Now, combining like terms on our top, I get 2 plus 11i over, combining like terms in the denominator, 25. And keep in mind, we have to write this as a plus bi form. So 2 25ths plus 11 25ths I. That is our answer.